G'day and welcome back to RC Model Reviews. I've got something from HobbyKing today. It's a 350 watt 23 amp Reaktor Pro power supply for your charger, because most 4-button chargers don't come with a power supply. You've got to hook them up to somewhere between 12 and 18 volts if you want to charge a battery, so you need something to power them. And I ordered this because I already tested the other power supply that HobbyKing offer, and there's a link to that review in the description of this one, but I thought I'd try this one out and see how it works. And it is about the same power, 350 odd watts. Difference being obviously that this one it's got a metal case, the other one has a plastic case, so you think, ooh, this must be better. But is it better? Well, one thing that was a bit disappointing was it runs on 110 to 240 volts, I think, somewhere it tells us. Yeah, or 100 volts to 240 volts, that's fine. I ordered it from New Zealand, from the international warehouse, and it came with one of these crap-ass pommy plugs that has a fuse in it, and oh man, it doesn't matter how hard I tried nailing this to the wall with a hammer, but it still wouldn't go into our Kiwi Australian connectors plugs on the wall because it's completely different. I don't know. Doesn't matter though, because it's an IEC lead, which means it's like that, so you can just steal one out of your kettle or your microwave or anything else and use that. So this can go in the rubbish. Right. Let's have a closer look at this. It comes with a manual. Let's have a look. Woohoo, got a manual. See, user manual in case you want to know. And it has all these things. It says warning, warning, warning. Do not put your children through the vent holes and so forth. Yeah, we'll use your rubbish. And it also came with this sticker that HobbyKing seems to be putting on a lot of stuff now. I can't get it apart because I've stuck it together. But it says warning, danger, danger. Your firstborn is at risk if you use this without reading the manual. Throw that in rubbish too. Right, so there we go. As I say, it's made of metal, which is a good thing because metal is strong, and more importantly, metal conducts heat well. So when this thing's blaring away, delivering its full 23 amps, then it's not going to get as hot as it might do if it was plastic. See, listen, metal, anodized aluminum on the end, very pretty gold color, power switch, yeah. On the other end, just a couple of banana plug terminals, either wire terminals, you can either wrap a wire around there, or you can stick a banana plug in the end, either way. Cool. It's got a fan which is blowing right down the length of it, so it's going to cool things down dramatically. We've got some good beefy heatsink material on the sides, that's all good. And so I can't see much wrong with it. Let's see if we can take the end off and see if bits fall out, shall we? Yeah, let's not just turn it on, let's take it apart, as Dave Jones from EV Blog would say. Right, as you can see, it's pretty conventional construction. We've got a printed circuit board here, and this extruded aluminum here provides a great way to build cases, because the top portion of this case should now just slide out. It does, look, I'm right. I mean, it's actually the bottom, I'm sorry. This is the bottom, so now we can see all the lovely electronic-y goodness inside. Let's take a closer look. Okay, from left to right, let's take a look. The mains comes in here, and somewhere in here there'll be a rectifier. There's a little fuse down here. I'll try and tip this up a bit so you can see. There is a fuse with some heat shrink on it, or a plastic covering, so if something shorts out, it's not going to burn your house down, hopefully. We've come in here, we've got a capacitor, we've got looks like a balanced choke there just to filter out some of the noise, another capacitor. These all just reduce the amount of noise that spits back down the power line, which is really important because the other HobbyKing power supply is noisy as hell. When I use that, my radio, I can't listen to it. So I should throw it on the spectrum analyzer, shouldn't I? Anyway, there we go. There's an earth lead from there. That looks all right, goes down to the circuit board. This has PFC on it. And normally in one of these power supplies, you have just one transformer to convert the mains voltage down to a lower voltage before it's rectified and comes out there. I'm wondering if this might be a power factor correction device, because switch mode power supplies are notoriously poor in terms of power factor. That means that the phase relationship between the current and the voltage, I won't go into it anyway, but basically it means that this will give a more accurate reading on your power meter, and also it can help reduce the amount of noise that is imposed on the power line. Now, there's your main filter capacitor. So once your electricity, your mains power has been converted into DC, so it takes it from your AC into DC, probably through these devices here. These are probably diodes down here. Then the DC is sent through switching transistors over here probably, or they may be diodes. Yeah, they'll be the switching transistors possibly. It goes into a transformer where it's all chopped up and comes out as lower voltage AC, which is then smoothed and goes through some diodes, or actually goes through some diodes, then it's smoothed, and then it goes out the terminals there. So hopefully that has given you a brief but somewhat cursory overview of how these things work. Now, I did notice one thing that I was not impressed with in the build. Let's take a closer look. Now here we have those diodes, and they're clamped against the side of the case here by this bracket. But if you look through here, you can see gap. Can you see the gap in there? There's an air gap, which means this bolt's on an angle. This hasn't been installed properly. It's actually not pushing on this side of that diode at all. So we might not get total heat conduction. There might not be enough pressure there to hold that diode against the case. Therefore, there's a risk that this diode could overheat and then you have a bang and it doesn't work anymore. So not very good quality control in the testing, in the assembly department there. Not very good at all. And another thing I always like to look at with these supplies is the quality of the capacitors used, because quite often capacitors are the first things to die in a power supply because they get hot and they have a lot of current flowing through them, and they tend to dry out, or sometimes they'll even boil the electrolyte inside and they'll burst. They have a little vent on the top to let the excess gas out, or sometimes a rubber vent underneath. And so the good brands to look for are Nippon Chemicon, Rubicon, and let's see what some Axon. Never heard of the bloody thing. It's probably a piece of crap. Well, it'll work, but it's not going to have a long lifetime. Is it a 105 degrees C rated capacitor? It doesn't say, so it probably isn't. 85 degrees C, there we go, it's got written on the top. In a power supply like this, where everything's going to get hot, you must use a 105 degree capacitor, because these things, they're only rated to 85 degrees C, which means that they will boil, they'll dry out, they'll stop working far more quickly than a higher rated capacitor. So I suppose you've got to take into account, though, this is a damn cheap piece of kit. Not expensive. What was it? I don't know, 30, 40 bucks or something, 35, 40 bucks. I forget the exact price. So you get what you pay for. And in that respect, this is going to provide, looking at it, a reasonable service life, providing that diode doesn't overheat. And so, you know, I'm happy with the value I got from this. I mean, it's not the best piece of kit in the world. It's not built to the best standards. It doesn't use the best quality components, but I didn't pay a fortune for it, did I? I only had to pay, you know, a fairly reasonable price. So I'm going to put this into service on my charging bench, and I'm going to come back in 6 months' time and have a look and see if it's still going, if it hasn't burnt my bench down. And I'll also be throwing these on the spectrum analyzer and see just how much noise they put out, because that is a really, really big thing. In fact, let's do it now. Actually, before I fire it up, I should point out one thing. Why would you buy this power supply over the other HobbyKing power supply? Well, one reason is that this is 15 volts output, I think. It does 15 volts, and that's quite important if you're trying to charge batteries that are quite big and you're drawing a lot of watts out of your charger. A lot of the 4-button chargers will not charge at their full rated capacity on a 12-volt power supply. They need more voltage to reach their full rated output. So if you're charging a lot of big 6-cell packs, then this is going to be a better option than the 12-volt supply or the 13-volt supply that HobbyKing offer. But let's fire it up. Let's see how accurate the output voltage is, and then let's look at it on the spectrum analyzer. And here is that other HobbyKing power supply in case you wanted to see a comparison. Also worth noting that these are both 350-watt power supplies, but this one's rated at 25 amps. This one's only rated at 23 amps. How does that work? Well, this has an output of 13.8 volts. This has an output of 15 volts. So if you multiply the volts times the amps to get the watts, you'll find they both add up to 350 watts. But this charger is going to be better for your heavy drain charger. This power supply will be better for the heavy drain chargers that you need to charge those big 6-cell packs with lots of capacity. So bear that in mind. Okay, let's check the radio frequency emissions of this power supply. As I said, I think it'll be pretty quiet because it's in a metal box, but the only way to find out is to turn on the power. And yeah, didn't really see anything happen there, did you? Let's change the frequency, but let's wind up in frequency and see what we get. I don't know what these, you get these little noise spikes everywhere. And I'll turn it off. No, so there you go, this is up to 444 megahertz, no noise. I'm happy with that. And the next test is to see what the output voltage actually is. So I've got my meter on there. Let's turn this baby on. This is without a load. 15.55 volts. So that'll probably drop down to about 15 volts when we throw a load on it. That's pretty good. Happy with that. So there we go. That's the Reaktor Pro 350 watt 23 amp 15 volt power supply from HobbyKing. And it's not the highest quality in the world, but it's pretty quiet in terms of radio frequency output. The voltage seems pretty much on mark. The quality of the components isn't that high, and the quality of construction leaves a little bit to be desired, but it doesn't cost a lot of money. So on the value stakes, I'd say it's a pretty fair value product. Now, as I say, I'm going to leave it running on my charging bench for the next 6 months, and we'll revisit it and we'll see how it's going, because the old one, I've lost it. Oh no, I've lost another thing. Oh, here we go. The old HobbyKing power supply, this one here, it's about the same price, maybe a little bit cheaper, as a plastic case versus metal. And this has been running flawlessly since I put it on my charging bench. So I'm really happy with this, although it's a little bit noisy in the radio frequency spectrum. There you go. If you've got comments, questions, anything to say, stick them in that part of the page where YouTube allows you to do so. In the meantime, I will clear my bench and get on with some other stuff. Thanks for watching. See you again soon.